Find the equation of a line through the 2 points. What's 2 things you need to know for an equation of a line? Slope, definitely. Y-intercept, that helps. If I don't have a y-intercept, a point will do. Right? Slope and a point will do. Slope and a y-intercept would be awesome if I had that. So what is the slope? And how'd you get that? Okay, any questions about how we got that? You could have subtracted backwards. Just make sure you're in the same order. Example, if you do 3 minus 5, then you have to do 1 minus -2. Right? So, 2 ways to write this. One, you could use slope-intercept form. If you use slope-intercept form, you put the -2/3 in for m, and you put an x, y, and for x and y and solve for b. How many of you, that's how you do this? That's how I did it when I was in Algebra 1 as well. I'm going to try to retrain your brain to use this equation. And there is a very good reason I'm doing that. It's not just because I don't like the way you once did it. In calculus, we get to quit simplifying things. We don't have to have things in slope-intercept form anymore. We're grown-ups now. And so because of that, slope-intercept form is more work because you have to solve for b. Does everyone agree with that? Not a lot of work, just a little bit of work. So I'm going to use the second form. It doesn't matter which y value you use, but if I choose the 3 for my y value, what do you think I must then choose for my x value? Y1.
Because that's the other coordinate.
That's the other coordinate to that point. This is called point slope form of a line. If you didn't know that, you will want to. So if it doesn't say otherwise, you can leave it in point slope form. We don't have to rewrite it into slope-intercept form. AP exam will even leave multiple choice answers in point slope form. So this is a set of formulas. Do y'all have a note card that looks like this? If you don't have it, you will want to know it. Now, you might want to read it first. Some of it you probably know, like the slope formula. The big thing you may not know and you need to know is point slope form of a line. You need to memorize that. It needs to be in your brain. Y equals mx plus b is also great to know. You need to know vertical lines are x equals and horizontal lines are y equals. You probably knew that from our horizontal and vertical asymptote discussion, but if not, general form of a line you can forget about for the most part. We will only use that if they make us. In other words, if that's the answer to a multiple choice question, that's the only time we would go to that. And we will if we must, but we won't try to. Okay. Did y'all have a note card that looked like that?
Yeah.
I thought you might.
Yeah. You start bringing the chart.
You need to know that the equation of a vertical line is x equals and the equation of a horizontal line is y equals. Okay, other important information. In real-world problems, slope will be called the rate of change. In your world so far, average rate of change is all you've ever been able to do. We'll work on that in calculus, getting better at that. But average rate of change is the slope. Vertical lines have undefined slopes. Horizontal lines have 0 slopes. Did y'all know that already? They are. And think about it. Y'all are advanced, so we can think about that. If the x values are the same, won't we divide by 0?
Right.
Which will cause undefined. If the y values are the same, we'll have 0 divided by a number, which would cause 0. So it makes sense. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Was this also on that same note card? Yeah, close enough. This is really probably not worth writing down, but Positive slope lines go up to the right. Negative slope lines go down to the right. Zero slopes are horizontal and vertical are undefined slopes. But can you believe this stuff's in that calculus book you have? It must be important. Okay, so find the slope. This is, oh my goodness, long time ago stuff, but hey, we need to make sure we can do it. Is this the bell ringer? No, it's still.
Yeah.
So, 2 minus negative 4 over 5 minus 3. That's how you find the slope.
3.
And the equation of the line. Now, again, I'm going to challenge you, not that it's a big challenge, to use point-slope form here. I'm not saying forget slope-intercept form. I'm just saying, hey, if I don't have to simplify, then that's going to be faster. You can imagine in calculus, these numbers may not be pretty. They may be fractions or pies or, I don't know, something weird. So solving for b could get yucky, and I don't want to do that. I'm lazy. So I'm going to use point-slope form. Questions about that one? Average rate of change. A moving conveyor is built to rise 1 meter for each 3 meters of horizontal change. What's the average rate of change? Why? Rise over run. Suppose the conveyor runs between 2 floors in a factory. Find the length of the conveyor if the vertical distance between floors is 10 feet. A lot of people look at this and feel like we have to do a conversion of units. I don't know meters to feet unit conversion. Maybe you do. I would argue I don't need to know. Why?
It's a 1 to 3 ratio.
It's a 1 to 3 ratio, right? Because this was in meters and this was in meters, so the 1/3 is a ratio with no units on it, right? So it doesn't really matter what the units are, it's still a 1 to 3 ratio. So the vertical distance is 10 feet. What would the horizontal distance be?
30.
30 feet. I don't know why I asked you that question, but sounds good. Maybe. Find the slope and y-intercept. How do you do that? Good. Get it in slope-intercept form. Find the slope and y-intercept. So the slope is, and the y-intercept is. You have to test this for me today, couldn't you?
Yeah.
There's like one hard concept to make. I mean, not really. It's like harder than this. Soon. Okay. I want the most efficient way to write an equation of these lines. I don't want just any way, I want the most efficient way.
Y minus 3. 3 minus 1.
More efficient.
Oh, that's the intercept.
It is the y-intercept, right? Okay. Do I have the y-intercept here?
Y minus plus 2.
He got it. Slope is 0.
I'm the only one thinking here.
What kind of lines have a slope of 0? So what's the equation if it goes through the 0.58? Is everyone okay with how we know it's y equals 8?
Just multiply.
X equals 3. Good. Any questions about those? So it's important to know what kind of slope a vertical and horizontal line has. Any questions about those? Okay. I don't know why people have a hard time with this, but this is messed up a lot. How do you find an equation with an x-intercept of 2, 0 and a y-intercept of 0, 3?
There's just 2 points.
Find the slope, right? 3 minus 0 over 0 minus 2. And then I do have the Y-intercept. Any questions about that one?
Is this supposed to be shorter than normal?
Maybe. It's a lot of stuff. It's like all Algebra 1 packed into one day. But it's Algebra 1. So, I mean, okay, any questions about that one? Plot the Y-intercept, use the slope.
Hey, what does the pi button do? Pi?
It makes me be able to write in math type, like I can write a square root or a... So when you see equations that look pretty, that's how I did it. Find an equation in general form. We'll do that just because it says to, but most of the time we won't. Parallel and perpendicular to the given line through the given point. So I want a line parallel to x equals 1 and perpendicular to x equals 1 through this point. Okay?
So the new line goes to that point.
Yep. Okay, so let's start with parallel. What kind of lines are parallel to x equals lines?
Why?
X equals lines. Vertical lines are parallel to other vertical lines.
So x equals -7.
And what about perpendicular?
X equals 1/7.
Y. Why y equals? Okay, I have a line that's vertical. What's perpendicular to a vertical line? A horizontal line. So y equals -2. Why -2?
Okay.
Because it has to go through that y value. So this was a trick question. When you were asked this question in Algebra 1, you probably missed it. You probably tried to flip the slope, make it negative, and do all kinds of crazy work, right? You just didn't think. That's right. But if you think about it, vertical lines are parallel to other vertical lines. Horizontal lines are perpendicular to vertical lines. So you can work those both ways. But do y'all remember that one being a hard question?
Yes.
I don't remember that question.
I remember about 3 things.
I don't remember who taught it.
So a more common situation when we talk about parallel and perpendicular lines is a normal line. So this is some line, and I want a line parallel to it and a line perpendicular to it. What do I need to find out about it? A slope, right?
Isolate y.
If I know something about a parallel or a perpendicular line, the big thing the original line gives me is just the slope. And so the slope of this line takes a little bit of work.
It's 2.
Any questions so far?
No questions.
What is the only part of that that's important to me? The 2.
Are you trying to find the reciprocals?
Maybe. I don't know. What am I trying to find?
Are you trying to find parallel or
You're trying to find
Okay,
both.
so let's start with parallel. How do you find
2.
parallel?
It's the same.
Slope is 2, and I know a slope and a point, so what would you use if you...
The y-intercept. The 1. Or whatever.
Point, I have a point and a slope, so I will use point, slope. You see how it's named that? I have a point and a slope. I use point, slope form. Ah, okay, now that's a parallel line, right? It did ask for general form. I do not ever go straight to general form. I work it how I want to work it and then change it to general form.
So distribute.
But just for fun. General form is ax plus by plus c, so we want everything on the same side of the equation. So negative 2x. Whoa. Okay. Put that down.
Yep.
Sorry about that.
Walk all over the board.
I'm sorry. Glitchy pin. It's a boy.
I told you.
Not really.
Can I get the board? It's John Woolman.
Okay, any questions about the parallel line?
Hey, Big John.
You made her get up. She's so pregnant.
I think I will be okay. You know, I can do things. I still run sometimes.
Sometimes. Not as much as you used to. Okay, I heard somewhere I was true.
I am videoing. Just a reminder.
And take your attention, please. Somebody has left an iPod up in the student union during a lunch. If it is yours, you need to go back and get it.
During a lunch. You ate a lunch. There was an iPod left in the student union at a lunch. He said it was his. He said it was his. But he doesn't have a lunch, so.
Sometimes I do.
No, you're always in here.
I think that's going to basketball games just to get things done.
Okay, perpendicular. The wonderful thing about perpendicular lines in point slope form, what's the only thing I have to change? The slope. On the AP Calculus exam, sometimes they will ask questions involving perpendicular lines, and they usually do point slope form. So all you have to do is that, and you're done. Now this one said general form. I'm going to comply because it said so, but
you don't have to do it.
It does have fractions. We'll do it.
Oh, okay, fractions. Yes.
Oh, okay.
Okay, generally, general form does not have fractions involved. Now, if you did, it wouldn't be wrong, but generally speaking, general form on a multiple choice question is going to have all whole numbers. So how could I get rid of all the fractions in this?
By 2.
Multiply everything by 2. So if you had to match a multiple choice answer like that, multiply everything by 2.
So general form you can have.
Some books define general form differently. It depends on how the textbook defines it. No math person really cares. So, because general form is just not useful mathematically speaking. So, so whatever the textbook you're using says, do it. But in general, you're not going to miss anything. Just when you have to match a multiple choice answer, you know. If it doesn't have fractions, don't put fractions. Okay, the last thing we're going to learn for today is symmetry testing. Do you have a note card that looks like this? That's how you find the axis of symmetry for a quadratic. Yes. To test to see if a function is symmetrical or not, does anyone have a note card that looks like this? If not, you might want to write it down.
You tried all that?
Yeah, or take a picture or do something.
I'll take a picture.
Do you have it? Nope. Okay, so no one has this one. You might want to write it down then. Nothing about symmetry at all? Okay, y-axis symmetry. You all know what y-axis symmetry is, right?
Yes.
Well, sometimes I want to find out algebraically if a function has y-axis symmetry or not. Well, to find out if something has y-axis symmetry, and if it's a function, it's called an even function if it has y-axis symmetry. You replace the x value with a negative x. If it gives you the same thing as a positive x gave you, you would have an even function. Well, let's talk about why. If we have y-axis symmetry, would you agree the values on the right and the values on the left are the same? That's why if you put in a positive x or a negative x, you get the same thing, because the values on the left and right are the same. X-axis symmetry, you replace the y with a negative y and see if you get the same result. Origin symmetry, you replace both the x and the y, because a positive x gives you a positive y, a negative x gives you a negative y. Those should give you the same equation. Origin symmetry functions are called odd functions. That those two words, even in odd functions, come up in calculus occasionally, and they expect that you know what they mean. Mainly, make sure you know that even functions have y-axis symmetry. Make sure you know that odd functions have origin symmetry. Do y'all remember learning this in Algebra 2?
Yeah,
okay.
I remember learning.
Just wasn't a note card. I missed one. I was one off on what I thought you had. It's pretty close, though. I was almost right. Okay. So we'll do some examples on symmetry, and that will conclude our day. Can't see the... Do I need to go down? Like that? Is that far enough?
Yes, that's good. Thank you.
And you can shortcut the wording there.
I know. If you go away. You probably
Where are we?
I'm almost done class.
I'm on.
Did you know that women tend to have smaller brains than men, but they're smarter because they use it more, or they use it better than us?
Use it there.
Use it better. It doesn't mean they're the superior gender. It means they use their brains more efficiently.
I imagine y'all's videos are slightly more interesting than others. Has anybody watched one at home? Is it?
That's pretty fun. I watched one once. It was pretty good.
It was good.
I watched it.
Subscribe to my channel. Subscribe to my channel.
Okay.
Get more stuff.
Back. I can figure out. Okay, now I don't want you to forget that some of these you could do in your head. I'm going to show you how to test, and I'm going to walk through each case algebraically. But isn't this a parabola moved down 3 units? And it totally has y-axis symmetry. Okay, we know that. Done. But just for fun, I'm going to show you how to test algebraically. To test for y-axis symmetry, you replace the x with a negative x. And I am going to keep it general, that way we don't mess it up, because it may work for one value and not all. So I'm going to keep it general. But what happens when you square a negative? It's a positive. If that happens, it has y-axis symmetry. Does that make sense? X-axis symmetry, you replace the y with a negative y. Is that completely identical to the original? No, so it does not have x-axis symmetry. For origin symmetry, you replace the x and the y, both with negatives. And that is not completely identical to the original, so this one only has y-axis symmetry, which you probably suspected from the beginning. Now, are there things you can look for? Yes. Now, it is tempting to immediately look at this one and call it odd. It's tempting. Let's find out, because I'm trying to trick you on this one. So y-axis symmetry, I replace x with a negative x. No. How do you know already? No.
It's cute.
Right. If I cube a negative, it's not going to turn out exactly the way it started, right? It's going to be negative. We could simplify that to see that. And I do not have to see all your work every time, although you better think every time because I can find ways to trick you. X-axis symmetry, what do I do? And does it have, yeah, I don't even have to go on, do I? The only y involved is squared, right? So it does have x-axis symmetry. Origin symmetry, I replace both, right?
No. It won't work.
It won't work. Why not?
Because of X.
So if like one of them, if you don't have both of them.
You can have origin without having both, but if you have both, you definitely have origin. But you can't have origin without having both. I will show you one of those.
If you don't have either one of them, then it's origin. If you have both of them, it's origin. But if you only have one, it's
Test all three. No. Test all three. Okay, this one. Again, it's nice to think before I work. What kind of function is this? Parabola moved left 3. Does a parabola moved left have any kind of symmetry? No. You can test it. None. That's not completely identical to the original, right? Nope. That's not completely identical to the original, right?
Right.
And then changing both is also not completely identical to the original. Now someone asked, can you have origin without having the other two? Yes. And you might mental note why it's called odd. An odd function. Why was this y squared thrown out of the odd function category? Because it looks like it might be odd.
Then you'd have to square root the other side. So.
It is odd. It's not a function. Right? The powers are odd, but y squared is makes a sideways parabola type thing. So you get a top portion and a bottom portion. So it's not a function at all. So it can't. Yeah, because it can't be odd, and that's why it kind of throws that out of the conversation there. But this one is odd. We check even, no, right? If I replace the x's with negatives, that is not the same as the original. If I replace the y's with negatives, that's not the same as the original. But what if I replace both?
You get.
At first glance, it doesn't look the same as the original, but what happens if I divide everything by -1? I get the original. So that one does have origin symmetry. So someone asked, can you have origin symmetry when you don't have x and y axis symmetry? Yes, you can, and that is a case where you can. Don't assume. Yes. Don't assume it's even or odd. I can't, like, a lot of people will see x squared plus x and go, that's even because of the x squared, but the x is going to mess it up, right? So be careful. Points of intersection by hand. How do you do that? I still have 5 minutes. I don't know where y'all are going. 3 options. Well, 2 options. Someone tell me what my 2 options are for finding points of intersection by hand.
Setting them equal.
Set them equal, so a substitution type thought. Find x, find y, set them equal. And what's our other option?
Plug it in.
Elimination. Substitution and elimination. Which one is the first one set up more for? It's an easy elimination problem. 5x equals 15, x equals 3. Does everyone know how I got that?
Yes.
And how do I find y?
Plug it in.
Put the 3 in for x, so I get y equals 5. So that's the intersection by hand. Can I do elimination on this one? No, I will have to do substitution. So I get x equals 1 plus y. So 1 plus y squared plus y squared equals 5. How in the world would I solve something like that? square. 1 plus 2y plus y squared plus y squared equals 5. So I get 2y squared plus 2y minus 4 equals 0. 2 divides out of everything. So I get y is 2 and y is 1. Why am I doing 2 points there?
Because it's 2 points. You gotta plug it in.
Oops. I have to plug those in to find x, don't I? Which one would you choose to plug? Bottom one. So 1 plus -2 is 1, -1, and 3. Okay. Intersections by hand. I think that's my last slide. Your homework is in the calculus textbook. Page 55, 2 through 28 even, 3, 38, and 41. If you didn't believe me that this stuff was important, because you probably thought, man, Miss King, why are we doing this? This is Algebra 1, right? If you didn't believe me that it's important, the calculus book thought it was important enough that they made it a chapter, right? So it's stuff we need to know, okay? Yes. We will grade the ABC packet tomorrow and review for the test. We aren't going to have a formal review assignment because the ABC packet kind of looks like a review assignment, but we'll talk about what's on the test tomorrow.